Hello everyone. In this lecture, I am going to discuss about the transformer and its uses and how it works. Some basic principle first of all I will discuss. This is some of the diagram of the transformer. Here it is a single winding transformer. Here you see here high voltage is coming this side and low voltage is taken outside. This is a case of the transformer where all the parts of the transformer are shown. This is the bushings where we connect wires of high voltage. This is low loss core is provided here. A rigid core clamp. These are some of the component. Here fans are also provided to cool the transformer. So many items are given here. So we will study about the transformer in detail and why it is being used uh, in case of a transformer. There are so many applications of the transformers are there, and we are using these applications. So our lecture in this module will be divided into the following categories. Like introduction, first of all I will see introduction of the transformer, then classification of the transformer, okay, how many types of transformers are available, we will see it. Working principle of the transformer, ideal and real transformer, what are the differences between ideal and real transformer. Then we will see equivalent circuit of the transformer. Testing of the transformer, transformers are tested to find the losses of the transformer before installing. So these things we have to study in this transformer. Testings of the transformer are open circuit test and short circuit test. These two tests we are going to perform to measure the transformer losses. And once we find the losses of the transformer through OC test and short circuit test, SC test, we will be able to find the voltage regulation and efficiency. Then we will see also auto transformer. Three phase is somehow I will explain three phase transformer also. So these are the some cases, some topic that we have to study in this module. So the definition of transformer. Here you see transformer. Why we study transformer? First of all, question arises: why we study transformer? So you see, if you go in at your street side in your locality, you will find a lot of transformers are placed here. So the role of a transformer is basically it either it increase the voltage or decrease the voltage. So we will study slowly what are the different types of role we have to encounter with the transformer. So, but here I give you an definition: device that convert voltage and current level from one electrical circuit to another via magnetic coupling without changing the frequency. This is the definition of a transformer. What is transformer? If someone asks you, the definition is device that converts voltage and current level from one electrical circuit to another electrical circuit via magnetic coupling. This magnetic coupling is the most important part, because without magnetic coupling, we could not transfer the electrical power from one side to another side in case of the transformer. So magnetic coupling is the very important part, and we need it. Without magnetic coupling, we cannot transfer the electrical energy from one side to another side. But here another important part is its frequency should also be constant. Its frequency should not be changed. Suppose one side frequency is 50 hertz, the another side frequency should also be 50 hertz. As we know, in our India, the electrical utility uses 50 hertz frequency. Frequency is 50 hertz. Some other country also uses 60 hertz frequency. So worldwide, two type of frequency is adopted, either 50 hertz or 60 hertz. If the voltage is increased, current decreases. If voltage is increases, then current has to decrease so that the product of voltage and current remains same. The output side is called a step up. If your voltage at the output side is increased, suppose this is your input side, this is input side, and this is your output side, output side. So if output side voltage is higher than this input side voltage, Vi input, and this is V output. So if V output is greater than V input, then your transformer is called a step up. If voltage is V output voltage here is less than V input, then this transformer is called a step down transformer, and in this case the current will increase. Here if voltage decreases, then current has to increase. In its simplest form, transformer, in its simplest form, a transformer has two windings that are coupled through magnetic core. So sources is connected to one winding called primary. Here I am giving you, this is your, suppose this is the magnetic core. This portion is magnetic core, and windings are placed at this side, and windings are placed also on this side. So this side, the side where we are giving supply, supply means our input supply is given, voltage source is applied here, that side is called primary. Giving here AC supply, only AC supply. The transformer works for AC. So AC supply we are giving here, and here load is connecting. So load, this is load, and load is connected here. So the side where load is connected is called secondary side, is called secondary side. So this side is connected load, so this is called secondary side, and here you see current will start to flow, and current will go here, 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 and again it will come back here. So primary side current is going like this. So this connection and this connection, they are physically not in contact. They are separate. Electrically they are separated also. There is no electrical connection between these two conductors. But the thing, when current is flowing, what will happen? A flux, as you know, that when electrical current is flowing, there will be a flux, and that flux, this flux will interact, go from this side to this side also. So this is the flux, and some flux also go into the air here. This is air also. So this flux is called leakage flux. You mind it, it is a leakage flux. And the flux which goes primary as well as secondary, that is called linkage flux. This flux is going, this is called linkage flux. Linkage flux. So this flux is called linkage flux. Those who goes into the primary as well as secondary. So this flux is called flux linkage. And here suppose you have given N1 number of turn, and here you have given N2 number of turn, and this is load is connected here. So here AC supply is given, so this current is AC. That is why flux will be also AC. So flux is changing. So a changing flux, when cuts this winding, induced EMF is produced. As per Faraday's law of electromagnetic induction, the magnitude of induced EMF will be d phi by dt. I am writing here magnitude, sign I have omitted here. And if N1 number is turned, so you have to multiply it by N1. For single number of turn, it is d phi by dt. Here flux is changing. You mind it, if flux is changing because the current is changing in nature. So this flux will be also changing in nature. So induced EMF will be produced in this winding. So same flux is also going here. So here also induced EMF will be produced. So secondary side induced EMF we can write N2 d phi by dt. Same flux is flowing here to here. So this is the secondary induced EMF and this is the primary induced EMF. If you divide both of E1 by E2, what you get? You will get d phi by dt cancelled out, N1 by N2. So this is one of the relation also, transformer relation with the number of turn. If number of turn N1 will be more, so E1 will be more. And if number of turn N2 is more, it means E2 is more. If E2 is more, then the transformer is a step up transformer. If E2 is a small, then transformer is a step down transformer. We will discuss this thing later also. But this circuit is very simple circuit, and this is the core, that is magnetic material. Magnetic, this flux creates a magnetic effect, magnetic field, and due to this magnetic field only the energy is being transferred from primary side to secondary side. Later we will see more detail. Windings are wound on ferromagnetic materials. This material is actually this material on which windings are placed. This is ferromagnetic core. Insulation is also a part of transformer to insulate windings and core. This winding is insulated. Insulated means some insulators are placed on this conductor and then it is wounded on the core of the magnetic material, so that these two windings are mechanically in contact but they are not electrically in contact due to the insulation. If you are not giving insulation, they will be mechanically in contact, also electrically in contact, and short circuit will take place and the winding may burn. To avoid this burning, we are isolating using this winding from each other by means of insulator. Same thing we are also providing here. Classification of transformer. So definition we have seen. Now we will see classifications, how transformers are classified. So transformers are classified based on the operation, a step up, a step down. Transformer based on the operation. This may be a step up or a step down. If voltage is secondary is high, then it is a step up. If voltage in the secondary is less, it is a step down transformer. So this transformer based on the operation, based on construction. There is also definition of based on the construction. So based on operation, transformer is two type, a step up, a step down. Based on construction also, how transformer is constructed. So it is a shell type and core type, two type of transformer we are based on construction we are using. Based on number of windings, single winding is there also in the transformer, that is called auto transformer. If single winding is given, then like this single winding is only available, then this transformer is some part of this portion we are taking as this input side we are giving, and some part of this is we are taking as output. So this is single winding transformer. This is called auto transformer. Two winding transformer we will study in this course. Two winding transformer that I have already drawn this circuit like this. This is the magnetic core and windings are placed on this side and this side. So this is your two winding transformer. And three winding, that is tertiary winding, is also available. That in your syllabus it is not available. So three winding transformer we are not going to study. Mostly we will study single winding and two winding transformer. This is based on the classification of number of classification of the transformer. Now transformer, basically it is transformer are two types of transformer we are encountering in practical uses. An ideal transformer may be ideal or real. In question also it is most of the time it is asked what are the differences between ideal transformer and real transformer. So ideal transformer is lossless device with an input with winding and an output winding. Means what is the meaning of this ideal transformer? Suppose this is core of the transformer and this is the winding on the primary side and this is the winding on the secondary side. So this winding transformer lossless winding means we are assuming this winding has no resistance, but in practical it never happens. It has some resistance, this winding has some resistance, but we are assuming here that there is a no resistance in the transformer primary as well as in secondary side. Resistance part is 0. Number of primary winding turn is N1. Here number of turn is N1. Here number of turn is N2. The voltage applied to the primary is here primary voltage. We are applying here as V1, and current here coming is I1. And here the voltage available is V2. V2T I am writing because its value changes with time. It is AC. So current in the primary winding is I1T and current in the secondary winding is, and turn ratio is defined as like this: N1 by N2, number of turns on the primary and number of turns on the secondary is denoted by turn ratio. You keep in mind it is not N2 by N1. Turn ratio is N1 by N2. This is the slight denotation what are values we are going to use in the case of the transformer. So V1T is the voltage applied to the primary side and V2T is the voltage available at the secondary side. Primary side is those side where we are giving the supply, means our source is connected here and here load is connected. Load means maybe your electrical geyser, heater, fan, tube light, anything maybe that takes electrical current is called electrical load. And turn ratio is N1 by N2. So this is the principle of working of transformer. So let us see some more example. When voltage is applied to the primary winding, it produces flux in the core. The flux flows through the core and link both the winding. That I have, these two things I have explained in the previous slide also. The time varying flux induces EMF in the primary and in the secondary. Time varying flux d phi by dt. This is time varying flux induces EMF in the primary, and also this induces EMF in the secondary side also. But for primary side here number of turn is N1, and for secondary side it is number of turn is N2 d phi by dt that I have already explained to you. The flux has two components, mutual flux and leakage flux that I have also. Mutual flux means flux linkage that goes into primary as well as secondary. Leakage flux which passes through the winding but returns through the air. It not goes to the secondary, it passes through the winding and return through the air. The induced EMF the secondary will cause a current to flow in when a load is connected. When this is suppose your secondary side, the secondary side is here, and if a load is connected here, like I am giving you one more example of the, I am going to draw again this circuit diagram. This is your circuit diagram. This is primary, this is secondary. So this thing you can also draw like this. The same thing we can draw like this. Here, this is N1 number of turn on the primary and N2 number of turn on the secondary, and two parallel bars are given here. This represents the core. This whole core of the transformer is represented by these two lines. And here if you connect the load, complete the circuit, then starting the current to flow, then I2 T start current flowing in the secondary side, and here in primary side we are giving the supply. So in this way, this transformer N1, this is a simple representation of the transformer of this representation. So I2 will start to flow in this case. If the transformer is ideal, what will happen? I'm going to discuss again this ideal characteristic. Again, I'm going to write some more thing about the ideal transformer. So if your transformer is ideal, what will happen? This resistance is negligible. And here the flux that goes into the air, leakage flux is 0. Means whatever flux we are giving here in the transformer, it all goes to the only core of the transformer. It is not going into the air. So leakage flux is 0 in case of ideal transformer. But in practical transformer, there will be a leakage flux. In practical transformer, there will be a resistance, but in ideal case, there is a no resistance. And in ideal transformer, whatever input power is here, the output power is here. There is a no loss. So V1 multiplied by I1 is equal to V2 multiplied by I2. So primary V volt ampere, this is volt ampere, current is measured in ampere, and this is your secondary volt ampere. So both are equal. So from here you can write V1 by V2 equal to I2 by I1. That is why this relation says that if I2 is higher, V1 will be lower. Inverse relation is there. If I2 is more, V2 will be less. So in case of ideal transformer, the core of the transformer is designed in such a way that its permeability, the core has infinite permeability. Infinite permeability. Core has infinite permeability, means whatever flux is coming here all goes to this core of the material. There is a no leakage flux in the transformer. So this is the ideal transformer, means I have told you there is a no resistance in ideal transformer, no power loss in the primary and in secondary, no leakage flux. All flux goes into the core of the transformer. But in practical transformer, there is a resistance, there is a leakage flux, and there is a also I square R drop. That is I square R, current square multiplied by resistance. If resistance is there, this drop will be there, and this will happen in case of the practical transformer or real transformer. So these are the some classifications which I have explained you and working also given you. Now some assumptions for ideal transformer. Again, I am going to give you the brief idea about the assumptions of the ideal transformer. Question may be asked, what are the assumptions for an ideal transformer? The winding resistances are negligible. Means already told you winding has no resistance. B saturation. This B saturation is infinite. What? Infinite. B saturation. Saturation flux density. What is the meaning of saturation flux? I am going to explain you. This term is very important for the designing of transformer in case of ideal. You have already seen the BH characteristic of this BH characteristic. Here it is H equal to N into I. N is number of turn, I is current, and this portion is side is B. This is the BH characteristic. This is current. Suppose here this current goes like this, and when we come back, it is not coming this path, it travels this path like this, and again increasing, then it goes like this. So this is BH loop. So this characteristic is called B. After this point, this line is in saturation. If you increase H, B does not increase. So this point is called B saturation. Saturate, it is saturated. What does it mean of means of saturation? So here you see, if you want, if you want to make the material such that the losses in the material is minimized, then you have to minimize this area of this area BH, this correct curve area you have to minimize. So I am just going to give another diagram for the same thing. Suppose this area, this is B, and if you want to have less area, what you have to do? This area, this area is less. So this current is also less, and area is less, and you see here B saturation has increased as compared to earlier. This B saturation value has this much, but if you reduce this H value, then desaturation will increase. If you further reduce, what will happen? If you reduce further H and H, then a time will come when B, it will look like this area. It will be like this. So B will goes to infinite when current I or H becomes 0. H equal to N into I. If your current becomes 0, H will be also 0. So during this time, what will happen? The saturation becomes infinite. That is why this is the case of the ideal transformer only. So what does it mean? If this saturation infinite, what does it practical meaning? It practical meaning is you are giving this transformer, suppose this is your transformer, and this is voltage applied, then this current start to flow in the primary. I'm just drawing here primary, and secondary is like this, drawing here secondary side. That number of turn is N2. So in this case, what will happen? So here, if you are not connecting the load, the secondary current is not there, but still there is a flow of primary current. Primary current is flowing. So where this primary current will go? Because we are not connecting load here, so secondary current I2 is 0. So without secondary current in the transformer, or without load current in the transformer, still there is a current in the primary side of the transformer. So where this current goes, where we use this current? So this current is used to magnetize the core of the transformer. This core of the transformer is magnetized by taking this current, because current is proportional to flux. Current is proportional to flux. This relation you have studied in your 12 physics. Li, you have also relation. L is the inductance. So this flux is used to magnetize the core of the transformer. So if the permeability of this material is infinite, but a permeability of relative permeability of this material is infinite, it means if this current produce, whatever flux is produced by here, all flux will go here. There will be no leakage flux. But if I is 0 here, if current is not given for ideal transformer, then here I equal to 0. Then you see saturation B, phi B is also equal to phi by area, flux per unit area is called B. If this flux value is 0, it means this current is 0. But in case of ideal transformer, here its value is reduced, so this B saturation goes up to infinite, very high value it takes, infinite. It means ki without taking any current, suppose if the current, but it is very small value here, then this has also a very big value. So almost negligible current is there giving here, still the core of the transformer is magnetized. This is the truly representation of saturation is infinite, means it is the core of the transformer never saturates and its saturation point becomes infinite. Permeability is infinite, therefore exciting current, this current, whatever current we are taking, when load is not connected there, this current is called exciting current, means this much current is the minimum current needed to establish the flux in the primary as well as in the secondary. Without this current, the flux in the transformer is not possible, and transfer of electrical energy from primary to secondary is also not possible. So this permeability of the material is infinite. It means all flux is going into this material. So one thing, I will give you a comparison between electrical circuit for your understanding. Suppose this is your electrical circuit and E is given here, and this is resistance, so I current is flowing in this case, so I will be equal to E by R using Ohm's law. If same thing you are considering here for magnetic circuit, then this resistance is replaced by another term that is called reluctance, and this current is replaced by flux. This current is replaced by flux, and this EMF here is replaced by MMF, this is called magnetomotive force. It is nothing but it is number of turn multiplied by current. This is called MMF. So duality is that if you write here for phi flux, it will be equal to MMF divided by reluctance. This is MMF divided by reluctance is called flux. So both are, this is also Ohm's law for magnetic circuit. So you also know this relation that resistance equal to rho L by A. So if you want a resistance very small, then this rho is called resistivity, and opposite of resistivity is called conductivity. So you can also write rho conductivity is written like sigma and A. So if you want this resistance has zero value, then this conductivity should be infinite. If it is infinite, then your resistance is zero. Then resistance will be zero. And resistance is zero, it means current will be very high flowing in this circuit. Same rule we can also apply here for the flux. So flux I am writing here phi equal to MMF divided by reluctance. So if your reluctance is, in this case, if your reluctance is very, very small, the flux will be very, very high. So how the reluctance relation, you have also studied this in your 1 upon mu r mu naught L by A. This is L is the length, A is the cross-sectional area, mu naught is the absolute permeability, means 4 pi into 10 to the power mu naught equal to 4 pi into 10 to the power minus 7, and this mu r is the relative permeability. If this mu r is infinite, I'm talking here, if your mu r is infinite, this mu r is infinite, then reluctance will be, if mu r tends to infinity, then reluctance goes to zero. If this reluctance goes to zero, this flux goes to infinite. So all flux will go into this circuit if its relative permeability is infinite. This is the case of the three positions is written for, four assumptions are given for an ideal transformer. This is the relation which I have already explained you earlier also. So this relation is the voltage and current relationship. So V1 equal to E1 induced EMF N1 d phi by dt, and V2 is the secondary voltage, E2 is the secondary induced EMF N2 by d phi by dt. If you divide this relation, you will get like this: V1 by V2, E1 by E2, N1 by, this is called turn ratio. And another relation was V1 I1 equal to V2 I2. So you can write this equation as V1 by V2 equal to I1 I2 by I1. So from here you see what is the V1 by V2 using this relation. V1 by V2 is N1 by N2. So you can also write this equal to N1 by N2, and it is nothing but it is N1 by N2 is turn ratio. This is called turn ratio of the transformer. So this relation is the very, very important relation for transformer, where we will where we most of the time in the transformer we will use this relation. So you should keep in mind that V1 by V2 equal to I2 by I1 equal to N1 by N2. This relation you have to keep every time in your mind, so that you can apply the this relation to find so many things like voltage, current in the case of the transformer. Okay, so in next lecture we will see other things.